So, good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on friction itself. So, let's begin with things. So, in this particular question, we are being given a block of mass 50 kg, an external force F is applied on the block, coefficient of limiting friction is 0.6, kinetic is 0.3, and here is the x-axis and the y-axis. The first question is normal reaction on ground by the block. So, block will push that downward with the force mg. So mg is equal to 500, direction will be minus of j cap. So that will be the normal reaction on ground by the block. Next is normal reaction on block by ground. So that will be opposite of this as per Newton's third law. So that will be 500 j cap. Next is limiting friction has a magnitude. So limiting friction has a magnitude mu limiting into n. Mu limiting here is 0.6, n is 500. So multiplying that we have 300 Newton. Next is minimum horizontal force needed to move the block. So minimum force is limiting friction, which is 300 Newton. Next is kinetic friction has a magnitude. So kinetic friction is mu k into n, which is 0.3 into 500, which is 150 Newton. Next is static friction has a magnitude. So static friction lies between 0 and limiting friction. That is, it will lie between 0 and 300 Newton. Next is friction versus force graph. So friction force graph, as I discussed, first it will be a straight line, then a kink, then kinetic friction. So this point will correspond to the limiting friction, which is 300 Newton. This point corresponds to the kinetic friction, which is 150 Newton. Next is acceleration time graph if f is equal to 10t. So we can say that initially acceleration will be 0, then it will increase instantly because friction will decrease, and then it will be